Okay, so let's get started. So, chapter 6.2, probability of a complement of an event. The complement of any event E is denoted by E prime, right? So the complement of any event E is a set of outcomes which are belongs to my sample space, but not in E. So remember, we had this same notation we used in chapter 3 under set theory. The E prime was denoted there by the complement of any set E. Here, the set, just a minute. Here, event E is my set. So if you look at here, the Venn diagram is very clear that E prime is here. This is, outside of E. Therefore, the outcomes, whatever comes from outside of E, is, in E prime. So in set theory, we had this guy as sample space was my U universal set there. So here we are using, instead of U, we are using sample space S. So there are very useful formulas we have here. The probability of any event E prime is the complement of that event E, is given by 1 minus PE. If you, move this PE to the left, you will come up with this formula. Therefore, altogether, we have three sort of formulas for, the complement of an event. The probability of any event E is given by 1 minus of the probability of event E prime, or the probability of any event E prime is given by 1 minus the probability of event E, or the probability of E plus the probability of E prime is always going to be 1. So these are the three important formulas we have under complement of event. Okay. So now, if you look at the example here, we are rolling a single die. Let E represent the set of events where we roll more than 4. Find the little ne prime, the probability of event E, and the probability of event E prime. First of all, we, find our sample space. Remember, you are rolling a single die, therefore you will have 6 outputs, 6 outcomes. My event here, E, is whatever you are getting the number which is more than 4. Of course, I have 2 of them. That is why my set E or event E contains 2. Once you know set E, now we know how to find E prime, the complement event E, that says that whatever we have in sample space excluding these. So if you don't have that, the remaining all the outcomes belongs to my E prime. Therefore, my E prime event is 1, 2, 3, and 4. Oops. Erase this. So that is my event E prime. Okay, so now we have everything. So little ne, the number of outcomes in set E or event E. If you look at here, there are 2. That's why 2. So any E prime, there are 4 outcomes. 4. So remember, recall the basic formula we had in 6.1. The probability of any event E is given by little ne over little ns. Right? So if you use this formula here, the probability of event E is ne over ns. My ne is now 2. Or what is ns here? Ns is the number of outcomes in my sample space. If you look at here, this is my sample space. There are 6 of them. Therefore, ns is 6. So if you look at this formula and apply here, you will get PE is ne over ns. My ne is here 2, ns is 6. Therefore, 2 over 6. In similar way, the probability of event E prime you could find either by using this formula, or I'm using here the complement formula. That is this one. If you use this formula, the probability of E prime is given by 1 minus the probability of E. The probability of E is here 1/3. Therefore, if you subtract 1/3 from 1, you will get the probability of event E prime. That is 2/3. Okay. So now let's look at those problems one by one. Problem number 1. A flu vaccine is known to be 98% effective. What is the probability that after being vaccinated, you will still get the flu? Remember, the 98% effective means what? We are almost safe, right? But that's 2% left, which is we are unsafe. Therefore, unsafe in the sense you will get sick. So the probability of getting sick or getting flu, if this is my event E, so if I use the complement formula, that is 1 minus P E prime, that is the probability of, if my event E is getting flu, that means my E prime is going to be not getting flu. The formula says that the chance of not getting flu, in another word, we are safe. So this is kind of we are safe. So the probability of being safe is 98%, which is 0.98. So if you subtract from 1, you will get the chance of getting flu, that is 0.02. Okay. So number 2. 30 students took a calculus exam. Of the students who passed the exam, 8 students got A, 9 earned grade B, and 6 earned grade C, and 3 and D. If a single student is randomly chosen, what is the probability that the student did not pass? So the question is now the probability of the students did not pass. If this is my event E, then according to my formula, this is E prime. So then what is the complement event did not pass? That is student who got passed. Okay. The formula says here, there are how many students got passed? If you add these all, you will get the total number of passed students getting A grade, B grade, C and D, that is 26. Therefore, the student got passed, the probability is 26 over 30, because there are 30 students. So if you subtract, you will get that probability, which is 4 over 30. So if you simplify, that is 2 over 15. Okay. Right. Now let's move to number 3. Let's read the problem first. The bags of the food are labeled 1 to through 50. What is the probability that the dog will choose a bag that is not numbered with a multiple of 11? Okay, so I'm leaving these 2 problems for you guys. Why don't you try these 2? So that's kind of a similar problem, right? So please try those 2. Okay, anyway, I'm going to do number 5. If we're going to do number 5, so let's look at the note given here. So what are they telling? Could you read this? When the probability of any event is complicated to calculate, sometimes it is quite easy to calculate the probability of E prime. So especially when E is described like at least or at most. What does mean by that? There are some certain situations where it is very, very hard for us to find the probability of given event E. So instead of finding E, I'm trying to find the probability of event E prime by using my complement formula E and E prime. Okay, so look at number 5. We are flipping 6 coins. Find the probability that we get at least one chase. Notice that the event that we get at least one chase is complement to the event we got nothing. Okay, what does mean by that? That means you are asked to find the probability of getting at least one chase. Okay, if this is my event E, formula says that is the probability of E is complements. Okay, but the note says that the complement of at least one is none. Therefore, the meaning of this guy is none of them are tails. Okay, that means what? That means in all the 6 coins we are supposed to get heads all. Therefore, the meaning of this guy is you are getting all heads. All 6 coins are giving heads. So this is the meaning of that. Okay. Now remember, in chapter 5 we learned the counting principles. So now here I'm doing 6 tasks. Therefore, you know, the probability of getting all 6 heads is going to be, for each we have half chance. Therefore, you have to multiply um, all the probabilities 6 times. One more half. Okay. Then this is going to be, if you simplify this, that is going to be 1 over 64. That is going to be 63 over 64. Okay. So what is the key point here? The key point is the complement of event at least one is none. Okay. Right. So now let's move on to number 6. We are rolling 2 dice. Find the probability that we will roll a total of at least 4. The second part, we will roll a total of at most 11. Okay, remember, so what is the sample space we had for rolling 2 dice? So if you roll 2 dice, my sample space has here 6 outcome there, 6 outcome there, for 36 in total. There are 36 outcomes. So remember, the sample space for this problem is going to be 1, 1, 1, 2, and so on. The last outcome is 6, 6. Go and refer your chapter 5. We had this. Okay. So now first part says what? You need to get the probability of the total number is at least 4. So what are the possible values for this? Remember here, when you roll 2 dice, the total here, if you add these two, you will get the total. If you get these, you will get the total, and so on. The minimum total, if you add the possible values are 1 plus 1, which is 2. The maximum total is 6 plus 6, which is 12. But here we are asked to find the total, which is at least 4. That means the possible values is 4, 5, 6, 7, 8, 9, 10, 11, and 12. So if you want to find the probability of such numbers, it's very hard for us because there are so many things we have to consider. But in that case, what I'm going to do is I'm just going to use the complement formula for that. The probability of event E is given by 1 minus the probability of E prime, right? So what is that E prime then? If my E has this kind of numbers, then what is my E prime has? Remember, in my all the possibilities, I have the total 2 to 12, but here I have 4 to 12. Therefore, the possible values for E prime, whatever left over from your, the numbers from 2 to 12. So obviously 2 is missing here, 3, 2 and 3 remaining are here. Therefore, the possible values E prime gets 2 and 3. Okay. Therefore, my E prime means what? The probability of getting total, which is 2 and 3, right? So remember, to get number 2, I have only one chance, that is 1, 1. To get number 3, I have 2 more outcomes, 2 and 1, 1 and 2. Therefore, in total, I have 3 outcomes. Therefore, the probability of getting total 2 or 3 is a 3 outcome out of 36. Therefore, if you simplify this, you will get what? 33 over 36. If you divide by 3, you will get 11 over 3, 11 over 12. That's my answer. Okay, so now let's move to part 2. We will roll a total at most 11. Oh, okay, now here, the probability of at most 11. If this is my event E, so what are the possible values you could have? At most, maximum 11. So the smallest possible is 2, 3, all the way up to 11, right? But it is very easy for us if you convert into complement formula, right? If my E getting these kind of values out of 2 to 12, right, the missing is only just 1, which is number 12. So my complement event is simply the total is 12. So that is easy. What is the probability of getting 12? 12 can be, got from 6 and 6. Therefore, that is just 1 out of 36. So it is 35 over 36. Okay. Okay. So now let's move to another definition of a union of two events. The union of two events, E and F, is an event formed by the outcomes. Remember, in chapter 3, we had the union of two sets, right? In similar way here, if you want to take the union of two events, simply we are combining the outcomes from both events E and F, right? The combined event is given by here, E union F. This is my, the combined event. In similar way, the intersection of two events is given by E intersection F, right? So you have two pictures exactly like I said here, sorry, Venn diagrams we had in chapter 3. So the first one is my intersection, the overlap region between, two events. Here you are combining, so that is why you are coloring both. Okay. So now we have a couple of formulas for the union of two events with the probability. Now, the probability of event E union F is given by probability of event E plus the probability of event F. Then you have to subtract the overlap event E intersection F. So you could use either one. So this is, I'm using notation, or here you could use in words. So I prefer to use notation, so I'm using this one. Okay, so the probability of event E union F is given by this. Okay, so now let's look at number 7. Problem number 7. Problem number 7. Find the probability union F if you know these things. Okay, so let me copy down my formula. The probability of E union F is given by formula says that is the probability of event E plus the probability of event F, then subtract the probability of overlap event E and F. Okay, but now the values are given, simply you need to plug in. Probability of E is 0.24, so this is 0.24. The probability of event F is given 0.88. Then subtract the overlap probability, which is 0.3. So if you simplify, you will get E union F probability. So that is 0.82. Number 8, find the probability of, now E intersection F is the question, but anyway, I'm using the same formula again. Okay, so now the question is this guy we don't know, but we know the union probability it is given, simply plugging the values, whatever you have. So this is a 0.82, and uh, you know the probability of E is 0.34. And do you know the probability of F? Yes, it is 0.86. This is the one I don't know, so I'm writing as it is. This is my problem. So now simplify this fraction and find out. Simplify these decimal numbers and find out the E intersection F. So if you add these two, you will get 1.2. Then we have negative sign of the probability of event F. So this side I have 0.82, and if you move this to another side and switch this and there, and you will get the probability of E and F. Simply 1.2 subtract 0.82. So what is that? That is 0.32, right? Is it correct? It's not correct, right? So it should be 1.20. You subtract, you will get 38, no? So there's a typo. Sorry for that. It should be 38. Okay. All right. All right. So you could try number 9 is in similar way, right? So you are asked to find, now PF is the question. So you don't know PF and then do the same thing like earlier we did, and it should be super easy. Okay. So now look at number 10. We drew a single card from the standard card pack. Find the probability that the card is king or spade. Okay. So number 10, the question is finding the probability of king or spade. Now, if this is my event E and if this is my event F, then OR is a union. If you use the union formula, the probability of E union F is the probability of E. My event E is king here. The probability of getting king plus the probability of F is spade. Then you have to subtract the probability of overlap. You're choosing one card. Remember, that should be king with spade variety. Okay. So the what is the probability of getting king? Remember, you are drawing only single card. In card pack, there are 4 kings. So it's going to be 4 over 52. Then how many spades there are? There are 13 of them. 13 over 52. Now remember, you are choosing only one card. That card should have, spade variety with the king. You will see such a card only one. So it is 1 over 52. That is going to be 16 over 52. You simplify. This is 4 over 13. Okay. Okay, so it should be 4 over 13, I think. Okay, so part B is similar, finding 10 or of phase cat. So the probability of 10 plus the probability of phase cat minus 10 with phase. And here the thing is, why it is 4 over 52? Ask yourself. Part B. Oh, this was part A. Part B says that the probability of 10 and phase cut or phase cut. So again, you have OR union. This is your event E and F. So this is the probability of getting 10, and plus the probability of getting phase cut. Then you have to subtract the probability of number 10 with the phase. Remember, there are 4 of them. There are 4 10 cards out of 52. And how many phase cards there? For each variety, I have 3. King, queen, and jack. There are 4 varieties. So 3 times 4, which is 12 then. There are 12 phase cards out of 52. Now I am subtracting the probability of getting 10 with phase. Remember, you are drawing only single card. So there's no way to choose number 10 with the phase card. For number 10, there's no phase. Therefore, this event is impossible. So therefore, it is an empty set. The probability of empty set is 0. So therefore, our answer is simply 16 over 52. So that is again 4 over 13. Okay. Okay. So again, there's a typo again, but again, here is the correction. I need to make the correction there. There should be 16, right? Okay, part C. Finding the probability that the card is red or face. Red or face. So this is event C, this is event F. So I'm doing the same thing here. The probability of red, probability of face, and subtracting the probability of red with face cards. So how many red cards there? There are 26. Remember, there are 2 varieties of red cards, which are hearts and diamond. So you have 26 of them. Face card again, 12 of them. And you are subtracting red with face. Remember now, there are 2 varieties with red cards, diamond and hearts. For each variety 3, therefore 3 times 2, which is 6. So if you simplify this fraction, is that 32? 26 plus 6, yes, 32 over 52 divided by 4, this fraction. So you will get 8 over 13. That is correct. Okay. Okay. So look at the last part of this problem. Find the probability that the card is neither a diamond nor a queen. Neither diamond nor king. If you look at this event, say this is event E, the complement of this event neither is going to be or. Okay, so I'm using the complement formula here. So the probability of neither diamond nor king is going to be 1 minus of, this is my E prime. Okay, So that is getting diamond or king. Now you know how to find diamond or king. You have to use the union formula to find this piece. And I'm finding that one separately first. So the diamond or king, the probability of diamond plus probability of king, they're subtracting diamond and king. I'm using the union formula here. So the probability of diamond is 13 over 52. So once you have an answer of this piece, just plugging here, this one comes from this step. So this one is here, this negative sign is here. So the probability of diamond or king is here, right? The probability of diamond is 13 plus the probability of king. There are 4 king, then subtracting diamond and king. So only you will find one such a card. So simplify these fractions, then you will get 16 over 52. Is that correct? 17 minus 1. Yes, 16 over 52. Then subtract from 1. You will get 52 minus 36 over 52. Yes, white. What I'm doing here. Is that correct? So this is 17 minus 1, 16 over 52. 52 minus 16 is 36 over 52. So 36 over 52 should be, this is not correct, 9 over 13. Okay. Okay. So I'm leaving this one as well. Okay, so now let's look at number 12. A deck of cards contains red cards numbered 1, 2. So red cards, there are 2 of them, number 1 and 2. And the blue cards, which has 3 numbers, numbered 1, 2, and 3. And the green cards, numbered 4, numbers 1, 2, 3, and 4. Right? Altogether, how many cards are there? There are 9 of them. Here 4, here 3, 4 plus 3, 7 plus 2, 9. Okay, now you are shuffling all 9 cards and you are drawing only one card randomly. What is the probability that that card is blue or has an odd number? Okay, so the question is finding the probability of getting card blue or you have an odd number. So this is my event E, union, this is my event F. So if you use the formula, P union F is P of E, that is the probability of getting blue, and plus the probability of getting event F, which is getting an odd number, then subtracting the probability of blue and odd. Satisfy these two. Okay, what's the probability of getting blue? How many blue are there? There are 3 of them. So it's going to be 3 over 9 because I have 9 cards in total. Plus, what is the probability getting odd numbers? How many odd numbers there? 1, 2, 3, 4, and 5. So there are 5 odd numbers among these 9 numbers. Therefore, that is 5 over 9. Then I'm subtracting the probability of getting blue. You remember you are drawing only single card. So that card should be blue color with the number odd numbers. So blue card has 2 odd numbers, right? Therefore, which is 2 over 9. So if you simplify this fraction, 5 plus 3 is 8 minus 2 is 6 over 9. That is 2/3. Okay. That is problem number 12. Okay. So again, I'm leaving 13. I just want you to try, please try this all. So it is straightforward. You are given a table, so you should be good with this problem. Okay. Now let's move to the last definition we have in this section. This is the finding the odds against an event E. The odds against an event E is given by simply the ratio of the probabilities of E prime and E, right? If you want to find the odds in favor, you just switch this fraction, flip this fraction. So then you will get PE over PE prime. If it is against an event E, put the complement first. If it is favor of your event E, then put that event first. Okay, favor is first and odd is second. Right? Okay. So now let's look at example B then. Calculate the odds against the event. Okay, now first of all, you had to figure out your event E. So this is my event E, right? What is that? You are rolling a single die. Your event E is rolling a number 5. Remember, this is my sample space. There are 6 of them. But getting number 5 is, of course, only one event. You have such an event. Therefore, my event E is just one number, one outcome. If my event E is one outcome, then E prime is going to be remaining all 5 outcomes. So first of all, I'm finding the probability of E. Formula says that NE over NS. So the number of outcomes in E is just 1 over the number of outcomes is in sample space is 6. So it is 1 over 6. So if it is 1 over 6, then P of E is going to be the remaining all outcomes, 5 out of 6. Okay? So first of all, you need to figure out P of E and P of E prime. Okay? Once you know these two, then the odds against events is the fraction PE prime over PE. Therefore, I'm just taking first PE prime, which is 5 over 6, then dividing by PE, which is 1 over 6, right? So if you simplify this fraction, it is 5. Okay. So the last problem. Calculate the odds in favor of rolling a total of 10. Now this is going to be my event E. First read the problem and identify your event E, right? So you are rolling 2 dice, therefore 36 outcomes. Among all 36 outcomes, number 10 total will be in 3 possible ways, 5, 5, 4, 6, and 6, 4. Therefore, I'm finding my probability of this event. So that is 3 over 36. Remember, this is my total outcome, right? 36. If PE is 36, 3 over 36, then how do you find PE prime? I use that formula, right? PE prime is given by 1 minus P of E. So P of E prime 1 minus PE is just 3 over 36. That is why I'm subtracting to find E prime. That is 33 over 36. Okay. Now the question is finding favor. So the fraction should be like this. First PE and PE prime. So I'm just plugging the values of PE and PE prime, right? So PE is 30 over 36 and PE prime is 33 over 36. So simply I'm simplifying this fraction. Will give you 130, 1 over 11, sorry. Okay, so in summary, here we had complement of event first. Then we had 3 set of formulas. Then we had the union formula. Then we had, at last, we had the odds in favor, in against, right? So make sure that you put the correct fractions. That's it.